Hi, fourth graders. It's Mrs. Mundorf here with your third science lesson for this week. We're going to begin today with a review of Energy of Light Day 6. The first part of yesterday's lesson was for you to watch two videos to learn about transparent, translucent, and opaque. You had to watch the videos and take notes. The first type of material, transparent, you had to write in the chart how much light passes through. And in a transparent object, all light passes through. What happens to the light with a transparent object? All light is transmitted. And an example of an object that is transparent is plastic wrap. The second type of material that we investigated was translucent. Some of the light passes through. So what happens to the light? Some light is transmitted. An example of a translucent material is wax paper. And the third type of material we investigated was opaque. None of the light passes through. What happens to that light? It is either reflected or absorbed. An example of an opaque object that we investigated was the mirror or a book. After learning about the words transparent, translucent, and opaque, I challenged you to sort the materials based on how light passes through them. The two materials we were investigating that are transparent are plastic wrap and a cup of water. The materials that were translucent were tissue, paper cup, wax paper, your hand, and notebook paper. And the opaque objects were the cardboard, the pencil, the book, the mirror, and aluminum foil. How do your answers compare? If you put something in the wrong column, please go back and fix it today. You then had to read a passage about reflect, absorb, and transmit, and highlight essential information. I highlighted when light strikes matter, it is either reflected, bounced back, absorbed, taken in and changed to heat energy, or transmitted, passed through. Often, more than one of these processes take place. Opaque materials do not allow any light to pass through. They either reflect or absorb all the light which strikes them. We then talked about the acronym RAT to help us remember what happens to light when it meets matter. It is either reflected, absorbed, or transmitted. And if light is absorbed, what happens to that light? It gets changed to heat energy. And yesterday's experiment was all about investigating how absorbed light changes to heat energy. The objective for the experiment yesterday was to observe what happens when light is absorbed by matter. The key words were absorb and heat energy. You had to gather the materials and set them up in a sunny spot. You had to measure and record your temperatures and make predictions. Based on your results, how well did you predict what was going to happen? Here's my observation chart for this experiment. I included a lot more times than you needed to, but I just wanted to show you how the temperature changed every hour. My black cup started at 77 degrees Fahrenheit. At 10 o'clock, it was up 10 degrees in 1 hour. My white cup, which started at half a degree warmer at 77.5 degrees Fahrenheit, was up less than 10 degrees, closer to only 5 degrees at 82.1 degrees Fahrenheit. So the temperature of the cup increased twice the amount of what the white cup temperature increased by. Then at 11 o'clock, the temperature of both cups continued to rise. The black cup measured 91.4 degrees Fahrenheit, and the white cup measured 86.2 degrees Fahrenheit. Again, the black cup was hotter still, more than the white cup, but it didn't jump the 10 degrees like it did in that first hour. At noon, the temperatures kept rising. The black cup measured at 94.5 degrees Fahrenheit, and the white cup measured at 89.3 degrees Fahrenheit. At 1 o'clock, the black cup was 96.4 degrees Fahrenheit, and the white cup was 93 degrees Fahrenheit. At 2 o'clock, it still continued to increase, but at this point, it increased the least amount since the time we started observing. At 2 o'clock, the black cup only measured 97.9 degrees Fahrenheit, and the white cup measured 94.4 degrees Fahrenheit. At 3 o'clock, again, the black cup raised by 0.1 degree. So it did raise, but not by a lot. But look at what happened to the white cup. It measured 93.8 degrees Fahrenheit. And then when we go to 4 o'clock, the black cup started to decrease in temperature as well. It went from 98 degrees at 3 o'clock to 97.1 degrees Fahrenheit at 4 o'clock. And again, the white cup continued to decrease at 4 o'clock and went down to 92.1 degrees Fahrenheit. Can you make a scientific guess on why the temperature of the water in the cup started to decrease at 3 and 4 o'clock? Pause the video and think about that. Using the observations you record in your chart, you need to use that information to answer these questions. The first question asks, was your prediction correct? I don't know what you predicted, but if you predicted that a black cup would have a higher temperatures after a couple of hours in the sun, you were correct. If you thought that the white cup would have a higher temperature, your prediction might have been incorrect, but it's not a wrong answer. This next question asked, which cup had a higher temperature at the end of your observation period? The black cup had a higher temperature. And the last question says, why do you think this is? And I wrote what I thought. I don't know what you wrote, but I said, I think this is because the black cup absorbs the light. And the last question asked you to really think about what you were observing yesterday. What do your results tell you about light being reflected or absorbed by black and white objects? I wrote, the black cup had a higher temperature, so it is absorbing the light and changing the light energy into heat. The white cup had a lower temperature, so it is reflecting most of the light and therefore does not absorb the light energy. Now, obviously, it did absorb some because the temperature rose, but not as much as the black cup. I then gave some other ways for you to investigate how we can tell light turns to heat energy. Did you try any of these extensions? The last part of yesterday's lesson was to read the passage on light, color, and heat and highlight essential information. I highlighted black and other dark-colored objects usually get warmer in the sunlight than white and light-colored objects because dark objects absorb more light energy. When light energy is absorbed by matter, the energy is changed to heat. The white object will not get as warm because most of the light rays are reflected rather than absorbed and changed to heat. We are going to begin our last big lesson on the energy of light today by looking at where do colors come from. Think about it. Why does a blue shirt look blue? What do you think causes a rainbow to form in the sky? Where do the colors come from? Where else have you seen a rainbow of colors produced? Pause the video and think about these questions. The objective for today's lesson is to understand why we see colors as we see them. The key words are absorb, reflect, transmit, and refract. The first thing I want you to do in today's lesson is to watch the BrainPop video on light. You're just going to click on this link and it will take you to the BrainPop site and this video. However, you will need to log in with the username parsley, lowercase p, and the password home 2020, and home has a lowercase h. After you watch the video, you should be able to fill in these blanks. When light travels through different materials at different speeds, it blank or bends. And light blank blank when it travels from air to liquid. If you cannot fill in the blanks, you must go back and rewatch the video. The next video I want you to watch on BrainPop is about color. Again, you'll go and click on this link. If it might still have you logged in, but if not, here's the username and password again. And these are the blanks I need you to fill in with this lesson. Blank blank is the waves we see on the electromagnetic spectrum. Our eyes register different wavelengths of visible light as blank. White light is a blank of colors, and objects blank different amounts of light energy. The colors we see is what is blank. Again, if you cannot fill in these blanks, you need to go back and rewatch the video. The next part is for you to watch a video about rainbows. Again, this is on BrainPop, so you should still be logged in, but if not, the username and password are provided. After you watch the video, you need to fill in the blanks. We see rainbows because blank is bouncing off of millions of blank. Human vision breaks visible light into 7 major colors, the same colors we see in a blank. And when light hits a raindrop, it is blank. If you can't fill in those blanks, you need to go back and rewatch the video. The next step is to read this passage on light and colors and highlight essential information. To show that you understand where do colors come from, answer these 2 questions. Why does a blue shirt look blue? And does a blue shirt always look blue? That's a little bit of a challenge question. I want to see if you can figure out the answer. After watching those videos and answering those questions, we're going to begin the experiment. The experiment today is about making your own rainbow. You're going to need a glass cup, some water, white paper, and sunlight. To begin this experiment, you're going to fill the glass 1/3 of the way up with water. Then you're going to hold the glass up so sunlight passes through the water. Then you're going to position the paper below the glass until a rainbow appears on it. So again, you can see me holding the glass, and then I'm moving the paper to see if I can find the rainbow. And you can see in this last image, there is a rainbow. You're going to repeat this with different water levels and at different times of the day. Then you're going to record your observations in the chart on the next page. I actually recorded my observations on a piece of paper, and then I'm going to type them into the chart later. Make your own rainbow observation chart. What did the rainbow look like? How did you hold the paper? How close did you hold the cup to the paper? At 9 a.m. or whatever morning chime that works for you, you're going to fill the cup 1/3 full of water. Then you're going to hold it over the piece of white paper and find the rainbow. Then you're going to add more water to the cup so it's 2/3 full. Again, you're going to hold that cup of water in the sun over the piece of paper and find the rainbow. And then you're going to do it again with the full cup, and you're going to hold it and put the light through the water and find the rainbow on the paper. You're going to do this 2 more times. I recommend if you do it at noon, or if you do it at 9, doing it at noon and 3 are good times of the day. If you don't start today until 10 o'clock, you could still do noon. I would though wait at least 2 hours. You really want a morning kind of you know, noon time or lunchtime, and then a early afternoon time. So remember, if you can't get this experiment done today or it's not a sunny day, you could always perform this experiment tomorrow. I know when I did this experiment, I was surprised by the results. So I'm interested to see what you think is going to happen and what kind of results you get. Have fun making your own rainbows today.